Converting angle measurements is going to be a skill that we're going to need to apply when we start talking about sector areas and arc lengths. And even when we start talking about solving, it's going to help us make relations. So in order to kind of introduce this concept of converting angle measurements, I first have an essential question for you to answer. And hopefully it's an easy one. How many feet are in 5 yards? Now, hopefully you don't have to take too long, but I'm going to go ahead and show the answer, but feel free to pause the presentation if you need some more time. If I were to do this, I would take 5 yards, and then I'm going to use my factor label strategy such that I know that 1 yard is equal to 3 feet. And so the strategy is such that the common unit goes on opposite levels of the fraction. And since the 5 and 3 are on the same level, that's going to tell us this is going to be 15. And you can see our new unit is feet. So therefore, there are 15 feet in 5 yards. Again, I don't think that was anything too mind-blowing there for you. But this strategy of a factor label method is what we're going to apply when we go and convert angle measurements. So the next question for us then is, what's going to be our conversion factor? In our problem with feet and yards, we had 3 feet and 1 yard because that's an equivalent measurement. So we want to view kind of like all of our angles within one rotation, and what would be the best conversion or best common factor to use? And that answer is pi and 180. Or in other words, we know that pi radians is equal to 180 degrees. Now, we could use any ratio if we wanted to. We could use 2 pi and 360 degrees, or we could use the pi over 2 and 90 degrees. But pi and 180 degrees will be our conversion factor for the following examples. So, what we have here is we're going to have the direction such that convert degree measures to radians, or if the question is given in radians, convert it to degrees. So in doing so, the process is pretty simple. We're going to use our factor label strategy. Since I can see that this is a degree measure, I'm going to use 180 degrees in the denominator and then pi radians in the numerator. In this, our degrees reduce, and then I'm just going to need to simplify 120 pi over 180, such that hopefully we see that 6 goes into 12 twice, so I get a 2 pi over 3, and that would be radians. The unit, again, is radians, and we typically have a pi symbol, but realize as you progress through your math levels, radian measurements don't always have to have a pi, because pi is nothing more than a number. Just keep that in mind for future lessons. The other way that the question could be asked for you then is it could be given to us in radians. So then what's going to happen is our conversion factor switches slightly because we're going to use the 180 in the numerator and then pi radians in the denominator. Now, I apologize, but typically I don't write the radian measurements, but realize that that unit is there. And here in simplifying, we see the pi's reduce. And then what I'm going to do is I'm going to reduce the 4 and the 180 also to make that a 45. So this leaves me with 5 times 45, which is 225 degrees. So in short, we just use our factor label strategy and realize that if I'm converting to radians, then pi's in the numerator. If I'm converting to degrees, 180s in the